when I'm presented with this quadratic equation, I'm going to go ahead and start solving him like I would almost any other quadratic by setting him equal to 0. So I'm going to go ahead and move that 4x over using subtraction, and I end up getting a quadratic in standard form of 12x squared minus 4x minus 11 equals 0. Standard form is my first step. Now, I wish I could factor. I really do, but there's no way I can factor this using a is not equal to 1. You can confirm that if you want, but it's just not going to work for me using regular integers. So I have to go through and use quadratic formula, which I've listed out right here. If I'm going to use quadratic formula, I have to identify a, b, and c. So 12, negative 4, and negative 11. I start plugging things in. I get x equals opposite b, so opposite of negative 4 is positive, plus or minus the square root of b squared. Now I'm going to square negative 4 as I go and get positive 16, minus 4 times a times c. And this is all over 2 times a. I always encourage everyone to go ahead and just simplify everything underneath the square root first. The discriminant is what we call it. So this is x equals 4 plus or minus the square root of 544 all over 24. Now I wish that 544 right here would be a perfect square. And if I check the square root, it is not. So I know that I'm going to have an answer that is irrational right here, irrational, because the square root doesn't go away. It's not a perfect square. So I have to go through and I need to simplify this like I do any other square root. If I want to reduce things from this problem, I have to reduce from 4 places at the same time. By 4, I actually mean 3. 3 places, right here, and a number out front. I have to reduce from all 3 of those places. Since there's no number out front yet, I need to go ahead and I need to simplify the square root to get one there. So over to the side, I'm going to recall that to simplify a square root, I do a factor tree. And if I do a factor tree on 544, I get 2 times 2 times 2 times 2 times 17, which is 5 2s and a 17. And I can pull out a pair of 2s, get a 4 out front. That leaves a 2 and a 17 underneath, which is a 34. So the square root of 544 is really 4 root 34. So I take what I had before, the 4 plus or minus, and go ahead and reduce that square root down to 4 root 34, and this is all over 24. And what this does is it allows me to reduce from all 3 of those places. Notice I cannot touch the number underneath the square root right here. I can't touch him. I can only reduce from these numbers out front. So if I divide each of those numbers by 4, I get x equals 1. Make sure you put that 1 there, plus or minus. I get another 1 there, but I'm going to ignore him because he's times the square root of 34, all over 6. So technically, I could just stop right there and get my answers. But since this is the first time we're looking at irrationals, I want to go just a little bit further. So one of my answers is I take the plus, 1 plus root 34 over 6. And that's a number. That number is irrational. It's a little hard to see. I mean, I never really said I have 1 plus root 34 over 6 chickens or something like that. So if I get the decimal, and I don't do this often, but he is approximately, when I plug him into the calculator, 1.138. Just so you can kind of wrap your head around what the answers are. One of my answers is approximately 1.138. If I take him and plug him back here into my original, he would make both sides the same. And if I take the minus, for my second answer, 1 minus root 34 over 6, he's an exact answer, which is great. I like exact answers. But approximately, if I put them in the calculator, I get negative 0.805. Just so you can kind of wrap your head around the fact that those are my 2 answers. They're irrational because the square roots didn't go away. I didn't have a perfect square. And they do have decimal approximations, but I like to leave them exact in order to present my answers without any sort of rounding error.